Very good morning, class. Today we are going to start the revision series for alcohol, phenol, and ether. Already I have explained the things. Here I will add some extra things also, which will be asked in your entrance exam like IRG and NEET and all that. So let's start with this alcohol, phenol, and ethers. So first we should know that what is how we can distinguish, how can we bifurcate them, separate them. So alcohol, it is ROH, that means aliphatic. OH should be attached with the aliphatic chain. This is phenol. Phenol, that means the OH group should attached directly attached with the benzene ring. Then it is called phenol. And the ether, which is having O functional group. So alcohol and ether, they are that functional isomer of each other. Okay, so let's start with this in alcohol, phenol, ethers. This is the layout. This slide is completely giving you the idea that what we are going to study in this series. Okay, so first we will do that types of like alcohol, monohydric, dihydric, whatever jo bhi, and then IUPAC name we will do. Then all that we'll do the preparation by alcohol and to prepare the alcohol, to prepare the phenol, then their physical properties, then reaction of phenols we will do, and then reaction of alcohol we will do like this. And this is electrophilic substitution reaction for anisole, that is benzene ring with the phenol only. So that we will do phenol ke saath, and this is anisole ke saath we will do some reactions. Okay, so let's start with this. In order of this, first we will start with this IUPAC nomenclature. IUPAC nomenclature, we all know that how to name it, that first we have to find the longest chain, and then numbering should be starting in that way, and from where the OH group, the hydroxyl group, should be at the nearest position. Okay, and then this is alkane minus E, OL, and it will give you alkanol. That means alkane formula CnH2n plus 2. If we will remove one H and add OH, it will give you the alkanol formula, alcohol form. So some PYQs for this. This is the IUPAC nomenclature. You are supposed to write that it has been asked in your paper board exam. So let's do the nomenclature. This is obviously counting. We will start from this position because OH is like near to this. Yes. So this is 1, 2, 3, 4. That means at 2 position there is a bromo. At 3 position there is methyl, and 1 position OH group all, and 2 position double bond is there. So just mention it, and it will be 2 bromo, 3 methyl, but 2 ene, 1 all. I hope it is clear. Another one. Although this is benzene ring, it has more number of carbon, but this is having functional group, so this will be considered as the main chain. Yani 1, 2. So this will be 2-phenyl ethanol. Yes. Now the third one is, there is again no problem. We have to start our counting from this side only. This is 1, 2, 3, 4. So that means 2 bromo, 3 methyl, butyl. I think this is the same. This one is the same, exactly same. Okay. So we can say that 2 bromo, 3 methyl, but 2 ene, 1 all. There is only that the way of writing is different. Otherwise, same compound. Now next one is, obviously we will start our counting from this side, because this is, although this is having long chain, but functional group is there. So that's why 1, 2, 3, that means 1 pe position pe OH group, and 3 phenyl. So 3 phenyl, 2 ene, 1 all. Now we will do the structure of the following compounds. So this is 2 methyl propane, 2 all. What will be the structure? Root word is 3 carbon. So make the 3 carbon over here, and then add 2 position OH and 2 position, second position CS3 methyl group will be there. Yes. Now the next one is 2 bromo, 3 methyl, but 2 ene, 1 all. That means the root word is of 4 carbon. So make the 4 carbon over here, and then 2 position bromine and 3 position methyl. Double bond should be at the second position, and OH group at the first position. Another one is 1 phenyl propane, 2 all. That easily you can do that. Propane, you make it propane, and then 1 position pe phenyl, and then OH at second position. Okay. Now some nomenclature for phenols. So phenols, for the phenol, benzene ring, if nothing is attached, then all the 6 positions are same for the benzene. But if benzene is substituted, then there is ortho meta para position. And we all know that ortho, just adjacent to the functional group or to the group attached to the benzene ring, is called ortho. Alternate one is meta, and exactly जो सामने होगा, exactly front पे what we say opposite होगा, that we will say para. So this is if phenol is having CH3 group, it will be considered as cresol. If phenol is also having CH3 group on either of its ortho meta para, then it will be called cresol. Only the naming will be changed. If it is at ortho cresol, meta, then metacresol, and if it will be on just samne, then it will be paracresol. Yes. Some PYQs for this. This is, you can easily name it, that is 2,4,6-trinitrophenol, and that is commonly called picric acid. So I hope you people are very much familiar with this. There is no problem at all in this. Now this one is that common name you have to learn for this. This is catechol, this is resorcinol, and this is hydroquinone. Okay. So IUPAC name, you can say benzene 1,2-diol, this is 1,3-diol, this is benzene 1,4-diol. Okay. Now next some other questions. This is phenol 2, and at the 2 position and at the 6 position there is a methyl group substituted, so that's why we can say 2,6-dimethyl phenol. Another one, this is, now there is a 2 functional group. One is this methox, like OCH3, you can say alkoxy, yes, and another is phenol. So phenol will get priority over here, and this will be considered, this is ether, and this is OH. So phenol will get more priority, sorry, OH will get more priority than this. So it will be, this will be phenol, and at 2 position methoxy group, and at 3, 4, 5 position there is a methyl. So we'll say 2-methoxy, 5-methyl phenol. Now the next is, this is phenol, and this is nitro group at whatever the position that you mention it, and it will be the name 2,5-dinitrophenol. Next is this is phenol, again 2 and 3 position pe there is NO2, so we can say that 2 1 second, this is 1, 2, 3, it will be not 2, 6, it will be 2, 3. 2,3-dinitrophenol. Now this is here OH group, although this is OH group, but we are doing under the phenol nomenclature, but here COH will get more priority than the OH. So this will be named as benzoic acid, and here OH will be prefix. So what name? 4-hydroxy benzoic acid. Okay, and second, if you can check, this is benzene sulfonic acid, which is the most prior group. Yes. So at 2nd position and at 4th position OH group is there. So we'll say that 2,4-dihydroxybenzene sulfonic acid. Got it? Now some other nomenclature for ethers. So for ethers, we know that this is alkoxy alkane. Yes, and alkoxy, that means the one which is having less number of carbon, that group will come with the alkoxy, and another will come with the alkane. While writing the common name, it is simply alkyl aryl we have to write, and at the end we have to write ether. Like this is CH3OC2H5, so we can write that ethyl methyl ether. But if we'll say that name, IUPAC name, we have to say alkoxyalkane, and which is having more number of carbon will be termed as alkane, and the one which is having less number of carbon will be considered as alkoxy. Okay. So write some IUPAC name for some other compounds. That is, this is the compound given over here. So obviously it is quite clear that this group is having more number of carbon. So obviously this will be considered as alkane. Okay. So this becomes ethoxy, isn't it? Now we have to start our counting from there only. 1 and then 2, and you have to go in long way. Okay. So that you will find the longest chain. So this is 1, 2, 3, and that means 2-methyl propane. So what will be the name? This is ethoxy 2-methyl propane. So here there is a like another equation, another form question given, that is C6H5OCH2 whole 6CH3. So what will be the name for this? In this case, just one side it is phenyl and another side it is 6 and 7 carbon. So which will be main chain? So here in that case, since number of carbon is more over there, so that's why C6H5 will be considered as the branch and it will be considered alkoxy, that means phenoxy, and here it is for 7 carbon heptane. Another question is that that C6H6 benzene, one hydrogen is substituted by NO2 and one hydrogen is substituted by OCH3. So OCH3 will get the priority over here and that's why this will become anisole, isn't it? This will be considered anisole and this will be nitro. So we can say nitro anisole, or we can say that for this 4-nitro methoxy, because it is para. So 4-nitro methoxy, this one will be methoxy and this is benzene. Anisole is a commercial name, so that also you can use, or you can say 4-nitro methoxybenzene. Now next question, write a structure of the following compounds. 1-ethoxy-2-cyclohexane. So here the root word you got, that is cyclohexane. At the second position you have to put nitro group and at first position you have to put OC2H5. So this is quite clear. You can do any place can be one. Yes, in this case this is one position, this is second, third, fourth, fifth, sixth. So 1-ethoxy, 2-nitro and cyclohexane. Now the next one is 2-ethoxy 1,1-dimethyl cyclohexane. So here cyclohexane is the root word, that means make the cyclohexane, and one position pe there will be 2-methyl group and at the second position there will be OC2H5. So this is the structure. I hope it is clear. Now next is phenyl isopentyl ether. So one side it will be C6H5, another side it will be isopentyl. Iso means that the group should be attached at the second position. So that's where that methyl group. So here it is isopentyl, that means the second, one second. This will not be the correct answer. The CH3 should be here. This is called iso because we will start our counting from this way. 1, 2. Yes. So at the second position, the methyl group should be there. Then it will be called isopentyl. So this is the structure. Okay. Now, just classification of alcohols. Alcohols can be of monohydric, dihydric, trihydric, polyhydric. According to the like name, mono. Mono means one. If there is only one OH, it will be considered as monohydric. That means here's the OH example. Like dihydric, that means there will be 2 OH group, then it will be called dihydric. And this is the best example, that is we say ethylene glycol or simply glycol also. This is glycol. Now this is trihydric. Trihydric, that means there will be 3 OH group and this is the name glycerol. Its common name is glycerol. And polyhydric, all the starch, cellulose, glycose, and this will be considered as even glucose. That will also come under polyhydric alcohol. Now this is like one page for this with the example, with the structure. Now types of monohydric. Monohydric, that means it will be sp3 hybridized carbon and OH group. That means the OH group will be attached to the sp3 hybridized carbon. Okay, so that is the monohydric alcohol and it can be of 3 types again. One is aliphatic, another is benzylic, and third is allylic. Aliphatic, that means it will be a straight chain, simple straight chain. Yes. Like you can see that. And again aliphatic is of 3 types: primary, secondary and tertiary. I hope all this thing is clear. The carbon with which OH group is attached is further attached with only 1 carbon, then primary. If 2 carbon, then secondary, and if 3 carbon, then it will be tertiary. Benzylic, that means there should be benzene ring. That sp3 hybridized OH should be attached with a benzene ring. That means the carbon with which OH is attached is should further attach with a benzene ring. Then it is called benzylic. That can also be of primary, secondary, tertiary. Yes, this one is attached with only 1 carbon, so it is primary. If I will remove this hydrogen from here and put the carbon over here, it will be secondary. And here, if I will remove one more hydrogen and put carbon, so this will be considered as tertiary. Okay, so this is tertiary benzylic halide. Now allylic. If we talk about allylic is again that sp3 hybridized carbon that should be further attached with the sp2. Here also it is sp2, but it will be considered as the benzene ring, and here it is only sp2 hybridized carbon. So the carbon, the sp3 hybridized carbon with which OH is attached, should further attach with a double bond carbon, then it will be called allylic. Okay, so this can also be primary, secondary, tertiary. This one is right now it is primary. If I will remove this carbon, this hydrogen with the carbon, it will be secondary, and if I will remove one more hydrogen, then it will be tertiary. Yes. Now the next thing, that CsP2, if OH group is attached with the sp2 hybridized carbon. Okay, the OH group is attached with the what? sp2 hybridized carbon. If it is attached, then it will be called vinylic alcohol. Okay, that should be aliphatic. Let me draw the structure like this. We can draw this OH is attached with this carbon, so this carbon should be sp2 hybridized. So let me draw like this, double bond with this. So this will be called vinylic alcohol. Now, methods of preparation of alcohol. How we will prepare the alcohols? There are lots of ways. So from alkanes having tertiary carbon on oxidation with cold KMnO4 gives tertiary alcohol. That can be it is not in general process. We do it in this is little costly process, so we cannot use in the conversion. Okay, whenever it is asked in the conversion, we will not ask this question, but this happens when tertiary there is a tertiary carbon. When it is oxidized in presence of KMnO4, this will give you OH group tertiary alcohol. Okay. Now alkenes, there are lots of ways by this alkenes we can prepare that alcohol. So there are the few methods already we have done in that detail. So let me do it in short over here. Alkenes can be converted into alcohol by following reaction. We do like HOH, H2SO4. If I will do the reaction with this this is called hydrolysis in presence of H2SO4 acid, then it will give you direct. Or in another way, first make it react with the H2SO4 and then hydrolyze this, then also it will give you. So all this, whatever these three, whatever we have done, these three will follow Markovnikov rule. Okay. Like the hydrogen Markovnikov rule, that means the alcohol will attach with that carbon where the double bond is, that double bonded carbon where the hydrogen is less. This will follow Markovnikov's rule. Okay. Now this one is Hg, like it is called, this reaction is we will do in detail. This is Oxymercuration-Demercuration reaction, it is also known as, and this one is BH3-THF reaction, Hydroboration reaction, that will follow the anti-Markovnikov. Here it is written Hydroboration reaction follows anti-Markovnikov product. Another is oxo process. In this when the alkene reacts with carbonyl chloride, in presence of carbonyl chloride and carbon monoxide and hydrogen, it gives aldehyde, which on further reduction gives alcohol. Okay, so this is the reaction. Now Oxymercuration-Demercuration reaction. Let's do with the mechanism. In the reaction, overall 1 molecule of water is added into alkenes or alkynes according to the Markovnikov rule. That means OH group will attach to that double bonded atom, that double bonded carbon atom where the hydrogen is less. Since carbocation is not formed, this is the point to be learned that carbocation यहाँ पे नहीं बनता है. Oxymercuration-Demercuration में there is no carbocation formation, and that's why कोई भी rearrangement या ring expansion और ring contraction नहीं होता है यहाँ पे. Okay, so be careful about this, that since there is no carbocation formation, so we will not go for any kind of rearrangement, any kind of ring expansion to make it stable. Okay, so this is like alkene, and when mercuric acetate reacts in presence and followed by hydrolysis, it will give you mercurial compound, hydroxymercurial compound, which on further reduction in presence of sodium borohydrate will give you alcohol. Okay, so let's do mechanism. Like this is mechanism of oxymercuration. This is double bonded carbon atom and what will happen? The bond will break. Suppose that this bond breaks over here, so this will create this bond breaks on this side. So suppose that this will be minus here and this will be plus here. Okay, so this is oxymercurial compound. What happened? So let me draw this structure. Actually, this is the mercuric acetate picture, formula. So when it reacts in presence of acid, what happens? This will in presence of any mineral acid. So this bond will come out as a, okay, and here it will create a positive charge over here. Hg has one lone pair too. So that's why it will be like this. So due to this plus charge, it will attach to this carbon, and due to this lone pair, it will attach to this carbon. So it will form a ring-like structure like this. And this is called mercurium ion. So here when in another step, what will happen? This bond breaks on this, and due to which water attack on this, and this bond breaks on this side. So it will form like this OHO. Since oxygen has lost its lone pair, so that's why it will be positive charge over there, and Hg like this. Yes. Now what will happen? This another H2O molecule, this H being better leaving group, will come out in presence of another water molecule to form H3O plus, and this will create a double bond, two lone pair over there. So this is called organomercurial alcohol or hydroxymercurial compound. That also it is known because hydroxy group is also there and mercurial compound is there. So that's why it is called hydroxymercurial compound. Now mercurium ion opening. How it opens? कैसे होता है? So water that we have already I have shown to you here like this. Water adds to more substituted carbon to form Markovnikov product. जो more substituted carbon वहाँ पे attack करता है, तो यहाँ both are same, so it can attack on any carbon. Water approaches through the mercurium ion from the side opposite to the ring. Ring के opposite side से आता है. That is also important point. That is anti-addition occurs over here. So this will form like this. In the another case, this is called demercuration reaction, the part of that. So what will happen? It undergoes reduction, and this will give you like Hg will come out as a reduced product, and acid, this is Hg. So this is Hg, and acetic acid will form as a side product, and OH, this H will attach over here, reduction, and that will lead to formation of 2-propanol. In the demercuration reaction, a hydride furnished by the sodium borohydride replaces the mercuric acetate. Okay, as I have explained. The Oxymercuration-Demercuration reaction gives the Markovnikov product with the hydroxy group on the most substituted carbon. So since in this compound it was same, so it can attack on both sides. It could attack on both sides, but in that where the number of hydrogen or the solution is more, we can bifurcate like this. So let me show you another example. And that is oxymercuration-demercuration of 3,3-dimethyl-1-butene. So in this case, or simple सी बात है that it will follow the Markovnikov rule. Okay, so Markovnikov rule, where the hydrogen is least, it will attach to that. यानी कि this H here it will attach, OH group will attach to this compound. So this is the final result. In the same way as we have done for that, the mechanism will be followed, and it will lead to formation of this compound. The reaction does not suffer from any rearrangement because there is no carbocation intermediate. I am marking it as again and again. So it is a very important point that there will be no rearrangement will be there. There will be no ring expansion, no contraction will be there to make this stable. Whatever it will form, it will be stable because what's the reason? Because carbocation is not going to form as an intermediate over here. So here I have few questions, just answer it. The simple thing is that these all are oxymercuration reactions, so we know that it will form only that according to the Markovnikov rule, and where the hydrogen at the double bonded carbon is less, the OH group will attach to that only. So in this case we can see that here and here the carbon is less over here, so OH will attach to this position, isn't it? So let me show you the answer. This is attached over here. Yes, in this case, in the both side, it will be same. Now, so again, which way you will apply? That bond is going to break on this side. Yes, more substituted part, more bulkier group, you can say that. So in this carbon is more like substituted, and this is only CS3, and here it is 1, 2, 3, 4. So that's why the OH group will attach to this position, and the answer will be like this. Yes, another way, again, this is double bond here and double bond here. So this carbon is having less number of hydrogens, so obviously the OH will be attached over here. So this is the result. In this case, again, the same thing, put two hydrogen, this is here and here. Yes, so here two hydrogen and here only no hydrogen, so OH will be attached to this position only. So let me draw the answer. Yes, it is like this. Okay. In this case, here also one hydrogen, here also one hydrogen, and no hydrogen, here also no hydrogen. So we will see that more alkylated group or more substituted group. So obviously this one is a more substituted group this side. So the bond is going to break on this side, yani ki OH will attach to this point, and the result will be like this. Yes. Now the next question is hydroboration oxidation reaction. The next reaction is hydroboration oxidation reaction. The hydroboration oxidation reaction is shown in the above reaction that converts an alkene into neutral alcohol by the net addition of water across the double bond. This is the point. The hydrogen and the hydroxyl group are added in syn addition, leading to cis stereochemistry. Okay, the hydrogen and hydroxyl group are added in a syn addition, leading to cis stereochemistry. That means it is going to form cis isomers. वहाँ क्या हो रहा था? In that oxymercuration, anti addition हो रहा था. Oxy जिधर से mercurial compound attached था, उसके opposite side से OH group water was reacting. But in this case, it will attack on the same side, cis formation. The hydroboration oxidation is an anti-Markovnikov reaction with the hydroxyl group attaching to the less substituted carbon. Yes, so यहाँ less substituted के साथ attach होगा, or the double bonded carbon atom where hydrogen is more hydrogen is more, there will be the their OH will be attached. So this is the reaction alkene when it reacts with borane and followed by H2O2 peroxide and sodium hydroxide, it will give you the alcohol, and the OH group will be attached to that double bonded carbon atom where hydrogen is less, hydrogen is more, sorry. Okay, so now next thing is from alkyl halide. Alkyl halide gives alcohol with KOH and NOH with moist Ag2O के साथ भी ये देता है alcohol. And even let me show you first. This is RX and this is NaOH के presence में we will get, and moist Ag2O के presence में we will get. Okay, so it says that mild base, this is mild base, so mild base gives the better yield. This will also, because again the strong base, and if it would be tertiary, it will lead to formation of alkene with like instead of this alcohol. So that's why mild moist Ag2O होते, that means mild alcohol, mild base, that will give the better yield. Now reduction of aldehyde and ketones also gives alcohol. So reduction of aldehyde is primary. So whenever it undergoes reduction, it will give you primary alcohol. But ketone is secondary. So whenever it undergoes reduction, it will give you secondary alcohol. So reduction by reducing agent, aldehyde gives primary alcohol. Like this reducing agent, you can use LiAlH4, you can use NaBH4, any other reducing agent you can use. And ketone always gives secondary alcohol. That is a reducing agent. Yes, using reducing agent, it will give you the secondary alcohol. Reducing agent, we can use lithium aluminum hydride, sodium borohydrate, ethoxide, sodium ethoxide, or sodium in presence of C2H5OH. Metal, we can use Zn, Fe, Sn in presence of any mineral acid like HCl, dilute H2SO4, even some CS3COH also we can use. Another reagent is aluminium isopropoxide, which is also called isopropyl alcohol. भी use कर सकते हैं उसकी जगह पे, and water also we can use for that. Yes, so that is the thing. Reducing agent aluminium isopropoxide or isopropyl alcohol in presence of water we can use as a reducing agent. In out of these three, out of all these five, the above three are the most common. Okay. Now next is something to remember, that is note: sodium borohydrate and aluminium isopropoxide reduces only carbonyl group and has no effect on any other group. So this sodium borohydrate, there is a limited reducing character, and aluminium isopropoxide reduces only carbonyl group. That means CHO और CO को ही reduce करेगा, इसका कोई effect other groups पे नहीं है. Like it will be act as a reducing agent, but only for the carbonyl group, not for any other group. Okay. Like this is also called crotonaldehyde. Okay, and this is we can say that but 2-ene 1-ul NaBH4. Whenever we reduce this, it will give you the OH. CHO will reduce to CH2OH. Yes. Reducing with the aluminium isopropoxide is also known as Mervin-Pondorf-Verley MPV reduction. Aluminium isopropoxide, if we are using as a reducing agent, it will be called Mervin-Pondorf-Verley reduction, and we know that aluminium isopropoxide is only used for reducing carbonyl groups, not the other groups. Lithium aluminum hydride has no effect on double bond and triple bond, but if compound is beta aryl or alpha beta unsaturated carbonyl compound, then double bond also undergoes reduction. Simply if we use that alkene and lithium aluminum hydride, it won't give you alkane. But if there is beta aryl group or any alpha beta unsaturated carbonyl compound is given, और उसके साथ अगर डबल बॉन्ड है, तो lithium aluminum hydride can reduce all that. Yes. Let's see this. This is here carbonyl group के साथ double bond है. So in this case, this will also be reduced as well as this ketone. Yes. In this case also we can see that this is beta aryl. Yes. Yes, beta aryl. This is aryl group. Alpha beta unsaturated carbonyl group इसको कहते हैं, because at the beta carbon this is alpha, this is beta, तो beta carbon पे carbonyl group is there, so that's why this will reduce this also as well as this also. So this is the point to be learned. ये important point है. NCERT में it's not there and it won't be asked in your board exam, but it is important for entrance. Now reduction of aldehydes and ketones. Reduction by Grignard reagent, and Grignard reagent has a very vast role. I will make another separate video for Grignard reagent and for lithium aluminum hydride, which will give you a very good idea about this reagent, that what they can do. Okay. So let's do from that few reactions we are going to use over here. So that let it be. This is RMGX Grignard reagent, alkyl magnesium halide. This R can be any alkyl branch, straight, कुछ भी हो सकता है, and this X can be Cl, Br, anything, but mostly जो होता है वो Br use किया जाता है. When it reacts with formaldehyde, it will give you the mechanism is that same way. This will break on this side, it will have minus and it will have positive charge, and this Grignard reagent will break on this MgX plus, and here it will be minus. So just addition reaction. So wherever it's a very short way we can do that Grignard reagent and any carbonyl compound reaction, that wherever the double bond O is there, just break the bond OMGX or make it OH. Final product I'm telling you, make it the that O double bond O, break this bond and this oxygen make the OH, and that oxygen with which this carbon is attached, उस carbon पे उसके alkyl group को attach कर दो, Grignard reagent के alkyl group को attach कर दो. So like here you just see what I have done. This make this OH. I have done this, and here it is R alkyl group. So on this carbon add the R. Simple you are getting, isn't it? The mechanism is that MgX will attach to this and this R minus will attach to this plus. So this will result in this one. Further hydrolysis, it will give you H will attach to this, and OH with this MgX will give you another complex, magnesium hydroxy halide. That means aldehyde, whenever it reacts with the formaldehyde, it is giving primary alcohol. If it is reacting with acetaldehyde, it will give a secondary alcohol. And if it will react with the ketone, then it will give you tertiary alcohol. So Grignard reagent basically like as I told you, it acts as a reducing agent. So it reduces the aldehyde into alcohol. Depending upon the type of aldehyde, it will give you primary, secondary and tertiary. Note, methanol cannot be prepared by this method. हम methanol बना ही नहीं सकते इससे, क्योंकि methanol के लिए there must be only one carbon. 1 second. One carbon, isn't it? So this carbon, if okay, let it be like aldehyde, we can take, but this, if I will put R over here, then it won't give you methanol, and if I'll not put R over here, it won't be considered as the Grignard reagent. So methanol cannot be prepared by this method. I hope it is clear whatever I have explained over here. Now reduction of carboxylic acid, acid chloride and ester. So there is some reactions. Let us do this. Reduction by lithium aluminium hydride. So if this group, whatever the group is there, okay, undergoes reduction in presence of lithium aluminium hydride, it will give you RCH2OH, and the group, whatever the group is there, that will give attached to this H. This group can be OH, can be Cl, can be OR. So if it is OH, it will be carboxylic acid. If it is Cl, it will be called acid chloride. And if it is OR, it will be called esters. Okay. Reduction by BH3. Boron also can be used as a reducing agent. So carboxylic acid and ester are reduced into primary alcohol by BH3. BH3 को यूज करके हम कार्बोक्सिलिक एसिड एंड एस्टर को डायरेक्टली प्राइमरी अल्कोहल में कन्वर्ट कर सकते हैं. एंड हियर इज सम एग्जांपल, लाइक दिस इज RCOOH. सो BH3 it will give you simply RCH2OH. Ester, this RO dash will give you another alcohol, and here it will convert into RCOCH2OH. Now reduction of carboxylic in that continuation only. Reduction of ether. So that is called Bouvard-Blanc reduction or Bouvard-Blanc reaction. When this ester, it should be ester, not ether. Okay, so reduction of ester, that is called Bouvard-Blanc reduction or reaction. When ester reacts with sodium in presence of alcohol, it will give you two type of alcohol, mixture of alcohol, and this is the one will be this, and another will be this alcohol. Okay. From aliphatic primary amine also we can prepare this alcohol. It reacts with nitrous acid to give alcohol. Nature of alcohol depend on the nature of carbon having NH2 group. Alcohol किस टाइप का होगा, primary, secondary, tertiary, that will depend on the carbon which is having NH2 group. If that carbon is primary, secondary or tertiary, on that it will depend. Reaction proceed through carbocation. यहाँ कार्बोकेटायन बनता है, so all the rearrangement or the ring expansion is possible over here. ठीक है, so that's why rearranged alcohol will be obtained. Like let's do this. This is NaNO2 HCl. It is also called diazotization reagent. Yes. So this is CH3, CH2, CH2, NH2. यहाँ पे this NaNO2 whenever reacts with this, it will give you primary alcohol as well as secondary alcohol. Again, as I said, that rearrangement can be occur over there because it will lead to formation of carbocation. So that's why the secondary alcohol will be the major product because it is the stable product, and this will be the less product, minor product. From oxidane. Oxidane is like cyclic ether. Okay, so by that we can prepare this. Oxidane react with Grignard reagent to give monohydric alcohol. And nature of Grignard reagent is basic, hence it attacks on the less hindered carbon of oxidane ring. Okay, that is Grignard reagent is basic, so it attacks on the less hindered carbon of oxidane. This is the oxidane. It is also known as epoxy, and epoxy nomenclature आपने किया हुआ होगा. Yes. So epoxy, this is epoxy कहो या फिर oxidane. This is like this. Now whenever the Grignard reagent reacts over there, so what will happen? This bond is on the both side. Both bond are same. So any side it will break. So if this break over here, this will have minus charge and this will have positive charge. Grignard reagent will break into MgX plus and R minus. This minus will attach to the plus and plus will attach to the minus. So this will lead in the formation of like this compound. Further it undergoes hydrolysis, and what will happen? This will give you MgO MgXOH, another compound, and here OH will attach to this. This will give you RCH2CH2OH. So this is less hindered. Here both were same, so that's why anywhere it reacts. But whenever it is 1,3-epoxy or 1,2 epoxy propane, so then we will check that less hindered जो carbon होगा उस पे OH group attach होगा. Now fermentation of carbohydrate, by this way also we can prepare this alcohol, like sucrose. When it reacts, when it undergoes fermentation, invertase enzyme की presence में, it will give you glucose and fructose, and glucose on further fermentation in presence of zymase enzyme, it will give you alcohol with the carbon dioxide. This is very common reactions and all the bio students are knowing this thing. So that's all about the preparation of alcohol. Now other things are also there, so we will do, and I will give you another video for this lithium aluminum hydride, and that is so Grignard reagent about that. So we'll do in that case, and next we will do some reactions, physical properties and chemical properties. So that will be in the next video. So we'll meet in next video. Till then, thank you class.